Here we have a 2012 Chevy Malibu with a 2.4 liter engine with a no start condition. Engine cranks, but it won't start. So let's start by scanning the vehicle and see if there's any trouble code stored. So DTC display, and we have one trouble code stored, or a P0230 fuel pump relay control circuit. Whenever you're going to run a test on an electrical circuit, you should always use a wiring diagram and analyze it first. Spend a couple of minutes understanding how the circuit is supposed to work. So always ask yourself that one question: how is the circuit supposed to work? Then number two will be, what is the circuit currently doing? So in this case, if you look at this diagram, the fuel pump relay, it's located on the rear fuse block on the left side of trunk, and your terminal 30 is connected to a fuse, and right here it says on the top, hot at all times. So that means you're going to have battery voltage regardless of the ignition switch position. Terminal 87 on most relays, it goes to the load. So in this case, our load will be the fuel pump. So if we highlight this wire, we can kind of follow the wire. And on some electrical diagram systems or softwares, you actually have options. So I can come here and select this I, click on it, and it takes everything off the circuit. At least it kind of hides the wires, so it could be easier to track the wire. And in this case, it goes to a previous page, terminal number 12. So if we select here for a previous page, terminal number 12 goes to terminal number 12, still same number, and it goes to the fuel pump. So if you notice, the fuel pump is located inside the fuel tank. The fuel pump connector, terminal number 2 is a ground at all times, and terminal number 1 will be the voltage to the pump. So we know that the pump is grounded at all times, and the relay is the one that controls the voltage. So if we go to the previous page, let's find out how is this relay going to perform this task. So if we look at the relay itself, terminal 86, it's a ground at all times. So that means terminal 85 should be a voltage to energize the coil windings of that relay to create a magnetic field and close the contacts between terminals 30 and 87. So if we highlight this wire, which is a dark green wire with a white stripe, it goes to the previous page, terminal number 4. Now if we see this, it's highlighted for us to kind of follow the wire to another page, and it goes to the PCM. This unit here is the PCM. So if we kind of move our diagram all over here at the bottom, it says engine control module, location of the module, and in this case it says on that terminal number 6 at the relay module, it's a dark green wire with a white stripe, says relay control. So that means the PCM is the one that's going to supply voltage to this relay. That is how the circuit's supposed to work. So we're going to run some tests, and we're going to find out what we're missing, and then we're going to go after that. Okay, so let's find out what is going on with the fuel pump circuit. The fuel pump relay on this vehicle is this relay here. So we could run some tests on the relay itself, but we want to find out what is going on with the circuit. So in this case, we're going to use an adapter. This is a fuel pump relay adapter where it has all the pins that are on the relay, and as we plug in the relay, you will have access to all the terminals. Your terminals here in this case is terminals 86 and 85. On the other side, you have the 87 and 30. So using this tester, it's a way to be able to access the terminals with the relay still connected and be able to find out what is going on exactly. without the circuit being interrupted. So we want to test it with the relay still connected on the car and find out what's going on with the circuit. Okay, so let's go ahead and check the circuit. In this case, I will be using a power probe to check for powers and grounds of the circuit and find out what the circuit is supposed to have and what is the circuit doing. So let's find out first. With the use of a jumper lead on one end of my power probe, the other end, we're going to go and connect to each terminal one at a time. So I'm going to go to terminal 30 first. Terminal 30, according to our diagram, should be battery voltage at all times. So that is terminal 30, and we measure 12.7 volts. That is source voltage. So that means the fuse, it's okay. We are getting the source voltage to terminal 30. Terminal 87 comes from the fuel pump, and we should measure a ground right now at terminal 87. So the ground is present. Now let's go ahead and check terminals 86. According to our diagram, terminal 86 should be a ground at all times, and that is terminal 86, measuring ground at all times. So terminal 85 should be a power source to the PCM. Right now we're measuring 0 volts. So I'm going to put my meter here, or my power probe. I'm going to place the power probe here. I'm going to go ahead and crank the engine. According to the diagram, the PCM is supposed to supply voltage. So let me go ahead and crank the engine and see if we actually measure that voltage. So as you notice, there is no voltage present when we crank our engine. So if there is no voltage present, you will not be able to energize the coil winding and supply voltage to the pump. Okay, so when we noticed that when we cranked the engine, we didn't get any voltage coming from the PCM. We're supposed to get voltage. Something else I did notice before moving any forward, I did notice this. I'm going to move my terminals from terminals 85 to 86. Notice that terminal 86 is ground at all times, but terminal 85, when I switch it, I don't have voltage. The voltage should be present when you crank the car, but I should be able to see the same exact ground that I see at terminal 86. So first of all, there's an issue here with this relay. Let's find out that first before we move forward. Okay, so let's find out what's going on with this relay first. This relay, terminals 86 and 85 should have a resistance somewhere between 60 and 100 ohms. The average, it's around 75 to 80 ohms on most relays at the coil windings. So if we turn on our meter to measure resistance, this is terminal 85 and this is terminal 86. The resistance here is 335 ohms of resistance. That is very, very high resistance on that relay. So first of all, we have a faulty relay. Let's switch this to a known good relay. So I have another spare relay here, a known good relay, and we're going to do the same thing, and we're going to move our leads to terminals 86 and 85. And our meter shows 86 ohms, which should be anywhere from 60 to 100 ohms. So if we put this known good relay watch our power probe as I plug it in. And the power probe is still connected to the terminal 85. This is the wire where the PCM supplies battery voltage when we cranked our car. Notice that as I plug in the relay, I do get a ground. That is a terminal 85 from the PCM. To 86 is the ground auto times. So if I move it to 86, that is the ground auto times. 85, the control side, I get 0. Now let me switch this so you can see it again. This is the relay that was originally on the vehicle. This is an on-go relay. There is a big difference. So let me go ahead and crank the car and see what happens. Okay, still no change. Now, with the usage of a scan tool, we could command the PCM to energize this relay. If the PCM is doing this, it's capable of controlling the relay, and if there is no problem between the relay control side and the PCM. So let's use our scan tool to command this relay. Under most scan tools will give you some features. In this case, it's called functional test. So we click on functional test, and that will be output controls. Under output controls, that means the PCM has the control of controlling all these components. Those are known as outputs. So we select the fuel pump relay. It says perform test with key on, engine off. So we're going to go ahead and continue. And when we do so, let's put this over here so we could also see. So we're going to go ahead. It says fuel pump can only be energized briefly. Otherwise, ECM may return device limit for activation limit exceeded. So that means if you energize it for too long, the PCM will disable that driver and you will not be able to do it again. It only allows you to do it for a short period of time. So if we go ahead and continue, whenever you run some tests, you will be able to see data display on some scan tools. So in this case here on the top, we have the option to turn it on or off. So if I turn it on, I should be able to see the PCM supplying voltage because I am connected at the control side of the relay. So let's say if we go ahead and do that, nothing happens. And time exceeded. Device control system exceeded. Output control timer expired. Please wait. So we're going to exit here. So sometimes to run this test again on the same circuit, you have to cycle the ignition off and then on again and perform the test once more. The PCM on this vehicle is right next to our battery. So we're going to remove it, probably place it somewhere else so we can have access to do some testing. Okay, so this is the connector for the PCM. According to our wiring diagram, if we reference the diagram one more time, terminal number 6 is a dark green wire with a white stripe. Number 5 is a dark green, and number 7 is not being used, and right after number 8 is a tan wire. We can use this as a reference to figure this out. And what we have here on this connector, we have a terminal number 1. In this case, this is terminal number 1, 2, 3, 4, 5, 6. So that's 6 wire. It's the green wire with the white stripe. Right after, it's a wire that is not a terminal that does not have a wire, and then we have the tan wire. So this is our actual connector for the relay. So the relay is currently connected. So that means we should be able to see a ground on this terminal. because the relay is the one that's making contact across terminals 85 and 86, and we should be able to measure a ground. Now, according to our meter, we don't have anything here. So it looks like we might have an open between the PCM and the fuel pump relay. The way we're going to use the meter, we're going to turn this on to measure continuity. Put the meter on the side, each terminal, attach it to our T-pins, and if we are backplug properly, we should have our meter showing that we do have continuity. So we do have good connection. Right. Now, something else to keep in mind. Since we know that this wire is the wire for the fuel pump relay. The fuel pump relay is currently connected. So if the fuel pump relay is currently connected, terminals 86 is grounded, goes through the coil windings to terminal 85 and go to the PCM at terminal number 6. So this is terminal number 6 at PCM. With my power probe, if I touch this terminal, that power probe should be able to measure 0 volts. You should be able to have a ground because the relay is still connected on the fuse box. So if we touch this terminal, there is absolutely no change here. So we do have a possible open circuit between the pump relay and the PCM. So let's go ahead and verify that. So it seems that we have an open wire between the PCM and the fuel pump relay. I currently have the PCM unplugged, and the wire that comes from the PCM, I have it connected to a ground. This is another way to check for an open circuit using a power probe. So a terminal that comes from the PCM is this one here right on top. I should be able to measure a ground, and there is no ground present because I am grounding the wire at the PCM. Now, if we look a little bit here on this unit, it seems that somebody has already tried to attempt to fix this. Somebody added silicone on this fuse box, and the wire, look at this wire here. This is the wire that comes from the PCM. The green wire, they're using this type of connector. This is not a really good way to fix wiring, and it goes on this end to the green wire with the white stripe. Let's see if we can remove this wire here. I'm gonna try to fix this right. So this is the green wire that comes from the PCM, and if I touch it with my power probe, there is a ground present. Let me turn off the speaker from the power probe. You can see there's a ground present. But on the other end, we're not having a ground because somebody has already tried to attempt to fix this car here for some reason. And we're going to find out, we're going to fix it right. And we'll find out if that will solve our issue or not. So this red wire, I have it connected to a ground from the chassis. And if we put our power probe and touch that wire, you can see that there is a ground present. Now on the other side of the fuse box, it's this wire here, and I don't have anything here. So we have a bad connection in this fuse box. Besides their attempt to fix this wire, it's a terrible job here. So let's remove the fuse box and see what we can do. All right, so we have disconnected our connector from our fuse box. Let's check first. I want to see if my fuse box itself it has any issues or not. Just keep in mind that this wire is currently grounded, and we should be able to measure ground on the other side, which is this terminal here. And as you can see, ground is present. If I turn on the speaker on my power probe, you should hear a beep. Okay, that tells you that is a grounded wire. So, not a problem with the fuse box, but we definitely have a problem here. Now, I kind of see multiple issues going on here, because that wire that we're testing from the other side is, according to this, will be slot number 1, 2, 3, 4. 1, 2, 3, 4, and you can see the fourth pin, it's all the way backed out, so it's not even making any contact. There's a problem there. But also look at here, there's another issue there, so that might be causing other things as well, other issues. So we need to fix this properly. We'll fix it, assemble everything back, and test afterwards. Alright, so after properly fixing the fuse box assembly, we can verify repairs. We still have our adapters. We have a power probe still connected at the PCM control side of the relay, and we can use our scan tool to verify these repairs. So we can always come here and select the functional test, output controls, and we can select the fuel pump relay. And we have an option to turn on this relay on and off. All right, so the power probe is connected to the control side. If we energize this relay by selecting the on, we are commanding the PCM to energize the relay, and you should be able to see that voltage present. So if we energize the relay now, select on, you can see the voltage, turn it off, voltage goes away. Now remember that when you energize this, the computer is just going to give you a couple of seconds. In some vehicles, not all, but in this case it has a timer. If we delay the timer, we have to wait a few seconds for or minutes, depending on the vehicle, to restart the test. So if we turn it on again, relay clicks, battery voltage present, turn it off, say the timer just went off, right? Time limit expired, but we're able to verify our repairs. Now we should be able to connect everything back, and our vehicle should run. Alright, we can also verify at the computer, at the PCM. Once we cycle the ignition, PCM should be able to supply voltage to the relay for a couple of seconds, and it will stop if we don't crank the car, because there is no RPM signal until we crank the car and RPM signal is present. The computer will constantly be supplying voltage to the relay. So let's go ahead and start the vehicle. As you can see, the PCM is supplying constant voltage while the engine is running. Problem is fixed. Turn off the car and the PCM will no longer supply voltage, and that's the ground we have that is coming from the fuel pump relay. I also ended up replacing the PCM. We had a bad fuel pump circuit driver due to the electrical issues that we found, and I would do a follow-up video to perform tests that led us to find a faulty PCM.